Hi GOR. We are starting constructions today. So this first video are 3 different constructions. First is just going to be an introduction to constructions. The second one is going to be copying a line segment, and the third one is going to be an equilateral triangle. So when you do construction, you use what's called a compass. So there are different kinds of compasses. The more traditional compass is a metal compass. It looks like an upside down V and it opens and closes, and one end has the pencil point. And then the compass that we use in school that I gave out to you if you asked for a compass looks like more like a ruler. So that introduction video will show you how to use the video and just how to do constructions in general. So when we're doing constructions, we're sort of using our compass to measure the distance, but not measure like in inches or centimeters or anything like that. We're using it to create circles or arcs. So I'm just going to read the top here. Geometric constructions have been around for about as long as geometry has. The first proposition that Euclid made was the construction of an equilateral triangle, and that's what we're going to do today. A geometric construction is simply the creation of a geometric object. That could be a line, a segment, an angle, a triangle, a square, and we're going to learn all of these. Here are the rules for constructions. A straight edge may be used, but only to draw segments or lines between 2 points. It is not used to measure. A compass can be used to draw a circle or an arc of known center and known radius. An arc is just part of a circle. No other tools except a pencil or a pen may be used. And the most important thing is you're not erasing your construction marks. I do recommend that you do them in pencil, so this way if you make a mistake it can be erased. This is the one thing on the regions that you are allowed to do in pencil. So as I said, we're going to watch 3 videos or 3 constructions here. The first one is just an introduction to constructions. You don't need to copy anything down at all. The second one is going to be copying a segment or constructing a congruent segment. So what I want you to do is, if you have the notes packet, you have segment AB already drawn. If you don't have the notes packet, just on a piece of paper, you can draw segment AB and you can follow along with the video. And we're going to practice all these tomorrow. And then the last one is going to be constructing an equilateral triangle. So again, if you don't have the notes packet, just draw segment AB. It doesn't have to be exactly the same length, that's fine. In this construction, Kirk from eMath Instruction is going to be doing it, and he's going to use the more traditional compass. So you'll get to see both compasses being used. All right, so let me play those videos for us. And here we go.
First of all, this is the type of compass that I use. There are the more traditional type. The more traditional type is pretty self-explanatory, but I wanted to talk a little bit about this one. The point of the compass, if you will, is actually this part right here. So anytime that I say we put the point of our compass on a certain point, I'm referring to this right here. This slider allows us to open and close the compass different distances. You'll notice that there's holes on both sides. The only thing you need to be careful of is, oftentimes in constructions we talk about we make a mark and then we have to make a similar mark without changing the compass. So make sure that if you use the outside hole, that when you make the corresponding mark that you use the outside hole again. I suggest to you that you get used to using one or the other and not switch back and forth as much as possible. I tend to use the inside, but there's really no difference between the inside and the outside. Whenever we make a construction mark, say I'm given a segment and I want to make a construction mark. So I'm going to put the point of my compass on this point right here, and then I want to make a construction arc.
So you guys don't have to copy what he's doing at the end. If you just want to pause it and you want to draw a dot and just practice making a circle with your compass and making sure that you're able to use it, that would be great.
When I put the point of my compass, I'm going to use 2 different colors, but since you're just going to be using your pencil, whenever you make arcs, you want them to be very light. You don't want to bear down on your compass, and you want to be very sort of light with it. One thing that I see students doing a lot of that I want you to not do is I see students going back and forth like so. That's not a good idea. These compasses tend to loosen up, and what you're going to end up with is you're going to end up with a very thick arc mark, and you don't want that. You want your arcs to be very subtle. However, when you are finished with your compass, with your construction, your tendency is going to be to want to erase your construction marks. Don't do that. You should actually leave your construction marks on the paper. So say you made a construction and you ended up having a point of intersection right about here for whatever reason. You created an arc. And so here's a point of intersection. When I connect these 2 points, I'm going to make a pretty deliberate line. This part you can make nice and dark. But I'm not going to erase my construction marks. I'm going to leave them right here because they give the instructor information on how you're doing. And it's just proper to leave the construction marks. At the same time, you want things to be very neat and tidy. Okay, you don't want to make a mess of your constructions. So that's just a little intro. The following videos are going to teach you how to do some actual constructions. Everybody's compass is a little bit different, so you're going to want to practice as much as possible to get used to not only your compass, but to get used to the steps for creating all these different types of constructions.
So this is construction 2, copying a signal.
Okay, this is creating congruent segments, constructing them. You're going to be given a segment, and you're going to be asked to construct a...
So you guys are going to practice this alongside with the video. So if you have the packet, you have line segment AB. Otherwise, you're just going to draw line segment AB in your notes. It does not have to be exactly the same as what was in the packet.
A congruent segment. The first thing that we want to do to create a congruent segment is we want to draw a ray, and the ray needs to be longer than the given segment. We'll give it an endpoint. We'll call that A prime. And now what we want to do is we want to measure segment AB. Now in the world of constructions, the word measure doesn't mean to actually measure and say, oh, it's 10 centimeters long. That's not what measure means. In constructions, measure means to open up your compass the length of the segment. So I'm going to put the point of my compass right on A, and I'm going to open up my compass as wide as the segment. So if I make an arc here, you'll see that that arc actually intersects point B. Without changing the width of my compass, I'm going to go to the ray that I drew. I'm going to put the point of my compass on A prime, and I'm going to draw an arc the same distance. This intersection right here would be B prime. And now, based on this construction, I am certain that AB is congruent to A prime, B prime.
And the last one is an equilateral triangle, and Kirk is going to be using this other compass.
Let's take a look at our first construction. Given segment AB shown below, do the following. All right, so we're just going to do step-by-step, follow the direction kind of stuff on here. Draw a circle whose center is at A and whose radius is equal to the length of AB. All right, well, I've got my handy-dandy electronic compass here. Now, on all compasses, there are two ends, right? There's the pointy end, and there's the pencil end. The pointy end will always go at the center of the circle, and the width of the compass always represents the radius of the circle. And remember, then all points on the circle will be the same distance from the center as all other points. So specifically, what I want to do is I want to put the center of the circle at point A as much as I can. I want to make the radius of the circle equal to the length of AB, and then I will draw my circle. Okay, so simple enough. Okay, not perfect, but simple enough. Do the same, but with the center at B and the same radius. Now that can be tricky because you might want to fold up your compass really fast, right? As much as you can, when you're using the same radius more than once, you want to keep the compass at that setting. So I'm going to leave it just just like that. I'm going to switch it around so my pointy end is right here. And then I will draw, whoops, and of course I lost it. That was unfortunate. But I'll draw my circle around like that, collapse my compass some, and put it off to the side. Okay, now keep in mind again, all the points on this circle lie a distance of AB away from A, and all the points on this circle, wherever that circle is, lie a distance of AB away from B. Okay? Letter C says, mark one of the intersection points of the two circles. One of the intersection points of the two circles, label this as point C. So I'll label that one. Okay? Draw segments AC and BC. Okay, well, let's take our straight edge out. That's simple enough. I will connect it to point A, rotate it up, and then do my best to draw that line segment in. Likewise, now I'll put it over at B. Again, draw the segment in, and get rid of my ruler. Okay, finally, explain why ABC, triangle ABC, must be equilateral. All right? Now again, we've actually done this construction, but it was way back in Unit 1. So let's think about that explanation. Take a moment and write down what you can. All right, let's do it. Maybe I'll just write the explanation up here. Okay? Because point C lies on both circles, it is a distance of AB away from both A and B. So, all three sides have the same, sorry about that, length. Right? All three sides have the same length.
Okay, so that's an ABC is an equilateral triangle because you used your compass to measure the distance from AB. Not measure it with a ruler, but you measured the distance between A and B with your compass. And then you made sure that when you put your compass on A and you drew an arc above, and then you put your compass on B and drew an arc above. Now Kirk, he drew full circles, and that's completely fine also. But C was the same distance away from A and the same distance away from B that A was from B. So that's why that's an equilateral triangle. And again, we'll practice all of these tomorrow.